So today's topic is performance tuning in IICS. So how we can do performance tuning? So performance tuning is nothing but in IICS in real time we'll be having simple jobs will be there, and then intermediate business logic jobs will be there. Some backup jobs will be there, and then complex jobs also will be there. Okay. So simple jobs is nothing but like one-to-one loading from OLTP to staging layers, and some intermediate jobs is nothing but doing some cleansing operation, like cleaning the data before loading into some intermediate layer. So and there will be some backup jobs also will be there. Let's say in 1 month the jobs will be running, and we might need to back up some data. Okay. So based on that also we will be creating some backup jobs, and there will be some complex jobs will be there. Complex jobs is nothing but there will be dependencies will be there. So there will be multiple dependencies jobs will be there. So all the jobs will be concluded in one mapping. Okay. So in that case, so we might be doing some performance issues. Okay. There might be chances. Sometimes the database might get down. Okay, database might get down due to some memory issues. Memory issues also, the system might will get down, or there might be some integration service, ISS integration service. They might be get down due to uh, node availability. Okay, so these nodes will depending on the organization. So in some companies they will use 6 nodes. In some companies they will use 3 nodes. In some companies they will use 10 nodes. It's entirely depending on the organization structure. Okay. So how many nodes they need to use for their integration service, which is nothing but IACS. So sometimes we'll be getting memory issues on each node, or they might be getting some connectivity issues. So there might be servers might be getting down. So based on these also, we might not able to run the jobs properly. Okay. So there might be overhead will be there on the servers, integration servers or database servers. So these are the major issues we will face in real time. And if we get any bad data from source, so we might be see some discrepancy in final jobs. So all the jobs will run on production, right? So for this production also we will be having one separate layer. It's like we have seen right from stage layer. Okay, from multiple to we load into storage staging layer. From here we'll be having from other intermediate layers will be there. So these layers will depending on the project. Okay, how they want to process their data. So how want to flow the data in their integration services. So this will be decided by the project managers or in team leaders. So in each layer, we will be having different logics will be implementing. So then final layer is production layer. Production is nothing but all scheduled jobs will be running. So all the scheduled jobs here will be running. So in production layer, so the final jobs will be there, right? Each job might be depending on another jobs as well. So once the depending jobs completed, then only it will in the final production jobs will run. Okay. So if we see some, we might be seeing, let's say one job, we have designed the mapping, and it should be completed within 10 minutes. Okay. And it was running properly. So let's say almost for 1 year, it was running properly. And after that, we have seen some issues due to some memory issues or some connectivity issues. So after rectifying it, once at that time the job was running, right? So when the job is running, it is taking more than 30 minutes. Okay. So before it was taking, so after some issues, after the rectifying all the root causes, after identifying all the root causes, and the issue has been resolved from the admin teams, from IICS integration team. After that, we observed that the same job before it was running 10 minutes and now it is taking 30 minutes. So at that time, what we need to do, we need to analyze that job. What is happening? Okay. So the first thing is what you need to analyze is first you need to look transformations. So what are the transformations they are using in the mapping? And obviously we need to get source target connections. Either it is a DB, flat file, or any cloud databases. Then we need to check. So look transformations we need to look, then source and targeted, and logic we need to check. So how the logic they have been defining. So if we have a sorter filter, so we can implement in source itself, right? So are there in any transformation they are taking extra transformations, or they are taking for simple operation they are taking some extra transformations instead of implementing in source itself. So that we need to check. So what kind of logic they are defining, and data, uh, from where the data is coming. Okay. So that we need to check, and what else we need to check? Hmm. So these are the basic things we need to check. Okay. So after this, so once the job run, right, here it is taking 30 minutes. Once the job is completed, so they need to download the session log, download the log, mapping task log, and you need to analyze this. So this you need to analyze. So the main thing is after checking all these basic things. So once you download the log, this is the main thing we need to, in this log only, right, we will get all the details. So based on this log analysis, we need to take some appropriate actions. So based on this only, we need to do the performance tuning. Okay. So in this performance tuning, we have two methods. One is PDO. So before it was like PDO. PDO is nothing but push down operation. Okay. Pushdown optimization. So now they renamed it as SQL-ETL Optimization. So now in IICS, we don't see this PDO, okay? We will see only SQL ETL optimization. And the second is partitioning method, okay? So these are all the two methods now we can see in IICS. In Informatica, we have like 4 to 5 methods was there. Same PDO, partitioning, and date range, hash key method, and then we have some more two methods. So now in ISS they have finally configured it as only two methods. Okay, PD1 partition. So what is this PD1? Pushdown optimization or SQL ETL optimization. So what is this SQL ETL optimization? So when you are clear, right? Till here.
Yes, yes, I'm following.
Okay. So SQL ETL optimization. So basically we will be having here source, transformations, and then target. Okay. So when we analyze this logs, right, after downloading the logs, we need to check where while reading it is taking more time or while transformations. In the transformation, we will implement the business logics. So here it is taking more time or while loading it is taking more time. So that we need to observe. So how we can observe is in the source, we can get busy percentage. Okay. So here we can see the busy percentage, how it is there. So whether it is nearly 100% it is taking or 0% or 5% or 80%, 90%. So if it is 90%, it is fine. But if it is reached 100%, right? So then we can confirm that. So from source, the main issue is we are getting at source side. Okay. If it is at transformation side, so we need to think that we need to optimize the transformation logics. If it is a target side, so then we need to look at target. So either we can implement indexes or stats, anything we can implement here before loading into the target. So after loading, we need to uh, drop the indexes which we created. So okay, first thing is we need to check the busy percentage. If it is percentage is more than 100% at source, so how we can implement RISE? So we will implement this SQL ETL optimization at source side. At source side is nothing but whatever you see all the this IACS what it will do. So if you take source transformation targets anything, whatever you write some override queries, but internally this IACS it will convert all into SQL only. Okay. So in its internal only it will write all the in SQL queries only. So if you take source, so it will write like select star from source that's and that way, right? So push it will push the this is target and in between we have transformation and it is source. So when you implement it at source side, we will get options. So when you go to this SQL ETL option, we will get here we will get drop down here source transformation target. Okay, we'll get three options. So based on the log analysis, you need to configure the property here. If it is at 100% at source side, then here you need to select like source. So When you select source, how this internally it will convert to the IICS, right? So it will convert all this target, transformation, and source. It will convert all this transformation into SQL, okay, and it will push into the target, okay. All this it will take as a source and it will push to the target, which is nothing but SQL optimization at source side. And if it is transformation side, source, transformation, and then target. So if it is just we are getting the busy percentage more at the transformation level. Whenever you run job, right, in the log you might have observed, so we will be getting threads, source, transformation, and right. Source is nothing but reader thread. So this is target is nothing but writer thread, and T is nothing but transformation thread. Okay. These thread by default it will create. Okay. So here, mm, yeah, how we will get 1 0 0 in this way. 0 1 0 0 0 1. Okay. So wherever you see one, right, first one it is a reader thread, and in between middle one is a transformation thread, and the last one is writer thread. Okay. So threads is nothing but it's a one flow, one data flow. If you are using more threads, so the data transferring will happen fastly. So if you take two flows, so you, instead of processing in one flow, you can process in two flows. So in this way, the data will move fastly from source to the target. Okay. And the target transformation, sorry, uh, the busy percentage is more at target. So in this time, this IICS, it will convert all the source transformation and target, all this into SQL, and it will push down to the target side. Okay. So I'll just show you this. So for performance tuning, so if it is a transformation side, okay, so if there are some logics have been implemented. So what we can do is to improve the performance, we need to use the joiner. So wherever we use this joiner, aggregator, rank, lookup, sorter, right? So we should get performance issues. Okay. So to eliminate these, if we are using joiner, so before that we have to use the sorter. Okay, if we use sorter before joiner, what will happen? The data will be sorted and it will be easy for the joiner to compare the columns, correct? So in that way, if you are using aggregator, so before aggregator also you should use sorter based on the sorting data. So it will aggregate the columns. In the same case, rank as well, in the lookup as well. Okay. To improve the performance, we will be using all these transformations. So source transformation writer. So these are the threads. So we need to see the bottleneck where the busy percentage is 100%. Either it is a reader side or transformation side or writer side. So if it is busy percentage 100 at reader side, then it is nothing but we need to implement this PDO at source side. The busy percentage at writer side, which is nothing but target. So we need to implement PDO at target level. If it is transformation side, I think we don't have. Okay. So in IICS, we don't have a transformation PDO. Okay. Only source and writer. In Informatica, we can implement at all three stages. So two methods are there: PDF pushdown optimization and partitioning. So pushdown optimization is nothing but converting transformation logic to SQL query and pushing down to source, target, or both sides. If you see busy percentage at both sides, the reader side and writer side. So in that case, what we can do, we will have an option called both. Okay. So both is nothing but it will convert all the transformation from source to target. It will convert all into SQL queries. And we have one more method. It is a partitioning. So in partition also we'll have two methods will be there. One is key range partitioning and then fixed partitioning. Key range partitioning is nothing but, so the name itself you can see key range. So if you have some date columns, okay, so you can give some 12, 5, 20, 2000 to 12, 5, 24. So we are defining the range from from starting this to the, this is Hindi. Okay, this is a range, right? So in between we need to do the partitioning. So it's like a key range. If not date columns, if we have a some transaction IDs will be sequenced as transaction IDs. Let's say some this range to from this range. So if we know the range, then we can use this key range partition, or else you can use fixed partition. Fixed partition is nothing but it's we can define this only on the flat file. If it is a flat file, okay, so then we can go with fixed partitioning. Fixed partition is nothing but by default we'll be having 1, 2, 3, 4. So we just need to define the sequence here. If it is 1, so this IICS it will understand that it is nothing but half. Suppose you have a 100 records, okay, so it will take 1 to 50, 51 to 100. Okay, this we will mention it as one partition. If you mention 2, it will do 100 by, it will partition in two parts, 1 to 50, 5 to 100. No, sorry. 1 is nothing but it entirely 1 to 100. Okay, that is one partition. If it give 2, it will take 1 to 50, 51 to 100. Okay, this is like 2. This is only 1. If you mention 3, it will divide 1 to 35, 36 to like 75, 75 to 100. So this is 3 partitions. If you give 4, 1 to 25, 26 to 50, 51 to 75, 76 to 100. This is like 4 partitions. So partition is nothing but all run parallelly. So when you run the job, it will create threads, right? Source, transformation, writer. Okay. So this fixed partition is at target side. If you are doing partition at target level, so what it will do? In target level, instead of one thread, it will create another one more thread based on the partitions how many you have given. If you give 4, right, so it will create 4 parallel writer threads. Okay, so in this way the data will load very fastly. Got it?
Yes. So can we
Yeah.
set the partition number based on the number of records dynamically?
But we don't know, right? We don't know, right, how many records we will get.
Yeah, but that is
If
based
you,
on expression. Can we count?
no, if it is a simple job, then you can get the count. But if it is a complex job, so how we will know?
Okay.
But we can define it. Uh, let's say if you take a fixed partition, okay. So once you run the job, you will know the count there, correct? So
Yes.
in the first
Yes.
run, so how many records has been loaded? What is the record count that you can see, correct? Yeah, based on that also you can define the partition level here. So how many you want partitions? So if it is a date level also, yes, you will know. So in the target, so what is the key range starting? What is the end range? Yes, you can also define the key range there. Okay.
Okay.
So the maximum partitions is 64. So till 64 partitions you can create in IICS. And all these are pass through only. It's like partition is nothing but only pass through. So we will not have any logics in between there again. So it's all pass through only. If it is a relational source, you can go with key range partition. If it is a flat file, you can go with fixed partitions. Okay. So the maximum partitions it will allow 64. So under schedule option, we'll have option called SQL-ETL Optimization. So there we can define this key range partition. Use a blank value for the start range to indicate the minimum value. Use a blank value for the end range to indicate the maximum value. If you are going with key range, right, at the starting you can define just like 0 and you can give in between the date range. And at the last, you can define just 0, and which is nothing but that is the maximum till end it will take. Okay. So fixed partitions, you need to observe some key points here. The maximum number of partitions that could be specified is 64 only. If the mapping includes multiple sources, okay, specify the same number of partitions for each source so that the data is processed in consistent pipelines. Partitioning is not supported when mapping uses a parametric source or source query. So if we have these two, we cannot implement the partitioning because these parameters will take from other files, right? And this query, source query also, we will be writing here some other queries. So if you do partitioning, we will get data consistency. So you need to make sure whenever you are going to implement PDO, so you need to make sure all these things. Partitioning is not supported when mapping includes hierarchical parser or web service transformations. Parameters cannot be used for key range values. If you have parameters, you define the parameter as a date column, okay? So in that case, you cannot use key range as a date. So these are the limitations we have. And so at RDMS level, how you can implement the performance tuning? How we can do that? Indexes you can create, collect stats you can create explain plan, and you will do the partitioning database level also, right? So you will use SQL hints to improve the query performance. So these all we will see in the while if you are a SQL developer, you might be familiar all these things, right?
Yes. Yes.
Yes. And we can go with error handling and stop on errors also. So in this way also we can handle the smooth data flow. Sessions are classified into fatal or non-fatal errors. Fatal errors is nothing but integration service would stop the session, service reading or writing, and roll back all the data is not committed on target side. So fatal errors is nothing but the errors which will come from the integration service itself. Okay. So those errors we call it as a fatal errors like metadata missing for source target table definitions or connection access issues. So we will be defining all these, right? connection details, and what is the table definition. We will be defining all things. So all these will be stored in integration servers. Okay. So while we are running the job, the Informatica is not able to communicate it, okay, to the integration servers or else the connection, whatever we defined it. If it is not able to communicate properly, then it is a fatal error. There are some non-fatal errors. The error won't stop the session. Instead, it would capture the bad or rejected records and load valid data into the target. We can set the session properties to halt or limit the errors. So non-fatal errors is nothing but which we will define it in the mapping, which we will not define. Those are fatal errors, which we can control the errors, which is nothing but non-fatal errors. Like in sessions, we can create stop, so metadata missing for source or target definition, table or view doesn't exist, stop on error like 0, 1, 2. In error handling, we can go select this option, stop. So we should give this values 0, 1, 2. 0 is what if you don't have any uh, errors. So if it is 0 errors, we are allowing. If it is 1 error, so we should stop it. Okay. Abort. Abort is nothing but to kill the process. Error. If the condition not satisfied, the session will fail with warnings and the good data will be loaded into the target. So this is just an example. If salary less than 1000, 1500, and what you need to get error like salary is less than 1500, comma salary. One or many conditions satisfies, this will load the valid records and fails. Okay. This is like stop an error on one. If salary less than 1500, abort. So if you want to abort it, if you are getting salary less than 1500, so how we can abort? You need to write abort salary is less than 1500. This is the uh, value you will get common salary. If it is greater than, then it will take obviously the salary data only. So one condition satisfies, this will abort the entire session and revokes the processed records. So it will not load any records into the target table. But here error is nothing but it will allow the records. Only valid records only it will allow, and then it will fail the session. It will fail the entire job. Okay. If you abort it, this will not at all process any valid records. Directly it will revoke all the process data and it will abort the job. Okay, this is the difference between stop, abort and error. Clear?
Okay.
Okay. So let's see how we can implement this pushdown optimization and partitioning. So what mappings we have here? So what I'll do, I'll just create one mapping. So okay, this is a simple mapping. So what I'm doing, I'm just loading from source to the target. Okay. So when I create a mapping task for this, click on next and runtime options. Here we will get it. You see SQL ETL optimization. Okay. So click on this, you will get this. So SQL ETL optimization type. To source to targets full. Full is nothing but both to source and target. Or if you want to pass this as a parameter, okay. So that also we can define. Let's say to source, and this is trial version, right? We don't see all this optimization context type fallback option. Mm. Save it. I learned this. So it has loaded the data. Now, if you download the session log, you can see the difference. So this is the task name. Okay, started by username. Session. Okay. So started SQL ETL optimization. Okay. So what this is doing? mm, So here it is creating the SQL select statement. Select source table and column name. Okay. And it is writing, and so how many columns we have? We have more columns, right? From the source table. Here also you can see the driver for the database connection and transformation source is Oracle, right? So ODBC style is SQL ETL. So now we have used SQL ETL optimization, right? So it has taken SQL ETL. So SQL ETL optimization feature is supported only for certain types of ODBC source and targets. Okay, now it has written SQL select statement, and then it has done SQL ETL optimization. Partitioning, we haven't given any partitioning. One second, let me connect.